Okay, good evening, sir. This is Trey Brand from Group 9. This is the assignment that is due the 31st of January, and this is my group with Isabel, Jubal, and Maxime.
Present.
So we are supposed to actually design a 4-bit ALU. Now the 4-bit ALU is going to be made up of 4 different 1-bit ALUs. So I'm going to go ahead and be putting the 4-bit ALUs, the 1-bit ALU, sorry. Okay, this is it. So basically this is it. Now the pins here are arranged anti-clockwise, meaning this one is the first input, this one is the second input, this is the third input. Also the top pins are the inputs, and the down pins are the outputs, and the outputs too are also anti-clockwise, meaning that this is the first output, this is the second, and so on and so forth for each of them. So now I actually want to be able to know the result of an operation for each of the ALUs. So actually, first of all, we have 2 control signals. In the design issues of this 4-bit, they said we have 2 control signals, S1 and S0. This is my S1 and this is my S0. So now for the displays of the bit, I actually have to put a display here and another display here. Now this first one is going to be for the output, the final output from this ALU, and then this one is going to be the carry over bit from this. So I have another display output, which is this one. I have another one which is for this one, and I have another one which is for this one. In case you might be wondering, the others are there and they are actually assisting me in picking the stuff. So now I have put all the displays, and now I'm going to go ahead and start connecting some stuff. So I'm going to connect the output pin to the bit displays. Okay, connect this, and connect this. Now that I've connected all of them, okay, I forgot this one. I connect this. Okay, thank you Isabel, thank you Maxime, thank you Juba for reminding me. I actually forgot that one. Now I have to connect this. Okay, now from the design we knew that the first one is supposed to be A, the second one B, the third one the carryover bit from each ALU. So I am actually going to go ahead and be putting that. Okay, so the third one is actually the carryover bit from the previous operation from the previous ALU. So I'm going to go ahead and put this one too. Okay, I'm going to go ahead and put this one too. Okay, so now I'm going to put I'm going to connect this, because after the carryover bit we have S0 and S1. So I'm actually going to start connecting. S1 goes here, S1 here goes here, S1 here goes here, and then S1 goes here. Okay, now S0 actually goes here for the first ALU. Yeah, it goes here. Okay, thank you Isabel. It goes here. Thank you Maxime. And this one goes here. Thank you Jubal. So now I have connected this stuff, and I'm actually going to put the inputs, which are the A0s, the B0s, the A1s, the A2s, and actually the C0 that I'm supposed to put. So I have them here. Yeah, it's true. I actually have to put this like this. Yeah. Okay, yeah. Okay, so this is it. So I'll do the connections. So I'm going to connect C0 here. Oh, sorry, I didn't do that well. So I'm going to select this and delete it. Okay, and then go back, connect. Yeah, okay. This is supposed to be B0. Oh, sorry, this is supposed to be B0. This is A0. Now I have B1 and A1. I have B2, sorry, B2 and A2. I have B3 and A3. So we have all the inputs in place. all the inputs from all for all the ALUs. We have the bit displays that will actually help us visualize the displays in real time, and we have the carryover bits that go from one ALU to the other. Here we have this originally there. This might be a carryover bit from a previously processed instruction. So now the use case, we're going to use a particular use case here. The use case we're deciding to use for the inputs is A0 equals 1 and B0 equals 1. C0 will be 0. We have A1 equals 1 and then B1 equals 0. Then we have A2 equals 0 and B2 equals 0. Then finally A3 equals 1 and B3 equals 1. So since we have, for the design issues, we had 4 scenarios, 4 issues design that we actually needed to know. Like when S1 is equal 0 and S0 is equal 0, we have the AND, so A and B. When we have a 0 and a 1, we have an A or B. When we have a 1 and a 0, we have A or B. And finally, when we have 1 and 1, we have A add B. So the first one, the AND, is going to be taken by Isabel. The second one, the OR, is going to be taken by Maxine. The ZOR is going to be taken by Jubal. And finally, I'm going to take the last one, that is 1 and 1, which is 1 add A add B. Sorry. So let's start with Isabel. She's going to go with AND. So Isabel, it's your turn.
Good evening, sir. I am called Isabel and I'm taking the AND. For the AND, when the S1 and S0, for the AND, normally the S1 and S0 are both 0. So for the input now, we have A0, which is 1, and B0, which is 1. The output will be 1 and a carryover of 0. For A1, you have 1, B1, you have 0. So the output will be 0 and a carryover of 0. For A2, it is 0 and B2 is 0. You have 0 and a carryover of 0. For B3, it is 1. For A3, it is 1 and B3, it is 1. And you have a result of 1 and a carryover of 0. So when we compute this, we will have 1 0 0 0 1. Exactly, sir. So the next command is the OR, which should be taken by Maxine.
Okay, sir. Good evening, sir. It's Tautia Maximilian. I am supposed to explain on the OR scenario. So A or B. Here the control signals are respectively 0 and 1. Okay. For the first ALU, we realize that A is 1 and A is 1, and B is also 1. So we have a result. We shall have a result of 1. And a carryover bit of 0, since we are dealing with a logical unit in this case. Now, secondly, on the second ALU, we have A as 1 and B as 0. For this case, we shall still have 1 as a result after we shall run. For the third ALU, we are having A as 0 and B as 0. Here we shall have a result of 0. Okay, and now for this case, where we have a 1 and a 1, we shall have a result of 0. Now the leftover will be 0. The leftover will be 0. So I will rapidly run this so that we can see. So as you can see, that's the result. So I'll leave my place to Mr. Jubal. Thank you, sir.
Okay, good evening, sir. I'm Jubal. I'm to do the XOR gate, and the XOR gate manifests when the S1 is 1 and the S0 is 0. Okay, that is for the XOR gate. Okay, so we have our input already here. Okay, as we can see, the carryover was 0, and we have a A0, which is 1, a B0, which is 1, and our output from the XOR gate will be 0, because when they are the same, the XOR will give a 0. And for our second ALU, we have A10 and A11 and A11 and B10. The output will be 1. Here we have A20, B20, and the output will be eventually 0. We have A31 and B31, the output will be 0, and the carryover will be 0. In fact, the carryovers for all the ALUs will be 0, because we are dealing with the logical unit. Okay, so we'll rapidly run this and see. Okay, so as we eventually said, here is 0, here is 1, 0, 0, and the carryover is 0. Okay, so thank you, sir. I'll leave my place to Brian to complete.
Okay, good evening again, sir. This is Trey Brian. That was Jubal, Maxime, and Isabel. Now I'm coming to complete the video. Okay, I'm supposed to be dealing with when the control signals are 1 and 1. That is A add B. Now, for the previous ones, we had 0, 0, 0, 1, and 1, 0. We're basically in the logical unit, but thanks to this 1, 1 now from the control signals, we're now in the arithmetic unit, meaning that the carry over bit here is actually going to play an important role. So now I'm going to go ahead and explain what happens and the expected result. Now we have A0 being 1 and B0 is 1, and we actually have C0, which is 0. So this is actually the sum of A and B and the carry over bit. So this is 1 plus 1 plus 0, which gives me 2. But since we're in the binary here, the result is going to be 0, and I'm going to have a carry over of 1. So after I have the carry over of 1, I get now 1 plus 0 plus 1, which gives me a 2. But since again we're in the binary situation here, I actually have a 0 again down here, and I still have a carry over of 1. So now I'm in the third ALU, and I have a 0 plus a 0 plus a 1. Now the result is 1, and I have a carry over of 0. So when I reach here, I have a 1 for A3 plus a 1 for B3 plus a 0. That was a carry over bit from the previous ALU, and I get a 2, which is just a 0 here and a carry over of 1. So basically when I run this, I should see my results, which are 0, 0, 1, 1 for the carryover bit and 0 for this output. So sir, this was actually fun again. A lot of research, it was amazing. We actually saw other things like multiplexers and how they work and how full adders and everything. So it was really nice. Everybody is here: Jubal, Maxime, Isabel, and this is our video. We hope you enjoy it, and if there's any error or any improvement you might think can help us, please you can actually help us with that. So have a good evening, sir. You have a wonderful night from all of us.
Good night, sir.
Good night. Okay.